Hey everybody, it's Michael Antonio, and welcome to Finding Constructs, another advanced AWS CDK techniques video. Okay, some notes. We'll be using my CDK orchestration library 0.1.18, and the code and slides for this lessons will be checked into CDK orchestration examples in GitHub. Okay, so the construct tree. If you want to make changes to the templates that are written out to your cdk.out directory, you're going to need to be able to find the L1 constructs in the construct tree. And here I'm giving you just kind of a little example of what a small construct tree might look like. It's got an app, there's one or more stacks in it. Those stacks may have some constructs, either L1, L2, or L3. In this case, you see we have an L2 bucket, which has a CFN bucket, which is an L1 construct. This is the construct that actually creates the JSON in the template.json file for your stack. There's also an L2 function construct. And when you create a function, it actually creates two children, a role and a CFN function. And the role is an L2, which has a CFN role as an L1. And the function itself has as its default child a CFN function, which is an L1. Okay, so when you get to much more complicated construct trees, when you're using a lot of like L3s, such as AWS Custom Resource or other L3s, or you have an awful lot of, sub constructs and you're using libraries and this and that, things get complicated very quickly. At some point, you'll want to visualize your construct tree so that you can find the actual construct that you need to change in order to modify the JSON in your template file. Now, Amazon provides three tools for visualizing CDK construct trees in VS Code. The first is the AWS Toolkit VS Code extension. I'll be showing that. It's a really great extension. It's got lots of really neat things in it, but we're going to be concentrating on the construct tree view within that. There's also the tree.json file, which gives you a lot of very detailed information about your construct tree. And then there's actually the generated CloudFormation templates. Each L1 CDK construct, when it writes out to the template.json file, it writes out some metadata, which is going to help you map back to the L1 CDK construct and find it in the construct tree. And so we'll be going through that today. Okay, let's say I want to edit a CDK bucket's cloud formation in the CDK. So we're going to create a brand new CDK bucket, new bucket. I pass in this, which in this case could be the stack, but it could also be like another construct. And then I'm going to give it an ID of my bucket. And this will create cloud formation for my bucket in the stack. Okay, but what it doesn't do, and in fact can't do, is add metadata to the bucket. It's because metadata is sort of a low use feature in CloudFormation. So the L2 bucket construct doesn't have any way to add metadata. We need the L1 CFN bucket in order to add metadata to the bucket or really to any resource. But how do we find that CFN bucket? Okay, well, there are two ways we can do it. We can navigate or search. And navigate is more traditional. We can navigate the construct tree to get to the CFN bucket. If I create a bucket, I can just get its default child. That default child will be a CFN bucket, so it's safe for me to do that cast here. As you can see, I say as CFN bucket. That casts the default child to a CFN bucket. Since this is a bucket node, we know that the default child exists. And therefore, we can just call add metadata on that and just pass in our key and value, and that'll end up in our template. Since it's an L2 construct, we can also find the child with the ID of resource, and that's usually the first child that is created. So it might very well be the first child of bucket if you tried to find it that way, but these are more sure ways of doing it, either going for default child or try find child resource as CFN bucket. So I'll get the CFN bucket. and then I can just call add metadata there. And will be the same CFN bucket that it would have gotten if I just called default child. I could also be a little bit of an anarchist and use the private underscore resource variable of bucket. That's probably not the best way to do it, but it works just as well. I can just cast my bucket as an any, then access the resource, which will be a CFN resource, and then I can even cast that as a CFN bucket and then call add metadata. So that'll work just as well. We can also do a search, and search is one of the capabilities that I developed for the CDK orchestration library. And so I'm creating a new construct tree search, and I'm doing that by calling construct tree search for. And this for method takes a predicate, and this predicate will return true if the construct that it is passed is a CFN bucket. And actually, this predicate does it as a type assert, which means that after I've called is CFN bucket, after that I can just use the variable as a CFN bucket. If you've ever seen how TypeScript works with type assertions, it's really neat. And we can do that, but here, I'm just using the fact that it returns a Boolean for construct tree search. So I'm creating a construct tree search for a CFN bucket, and then I'm going to search down the tree starting at the bucket, and then I'm going to pop the results. So search down, basically it starts at a node. So if I gave it the stack and I looked for CFN bucket, since there's only one CFN bucket in the stack, it would find the CFN bucket and return it. If I passed the bucket or the CFN bucket, it would similarly return the CFN bucket. If I pass the function, nothing would be returned because there's no CFN bucket under function. Okay. And then since I now have a CFN bucket, I can then call add metadata and just pass in my key and value as I did above. Now, why would I want to do something as complicated as creating a search? Well, it's because the search is pretty powerful and you can do a lot with these searches. So, for example, and I believe that I showed this in the previous video on tokens. If you want to go take a look at that, you can do a construct tree search for stack.isStack. So this is a built-in predicate. There are lots of built-in predicates in the CDK. Not every class has one, but here we have a construct tree search for stack, and I'm going to search down starting at the app, which means that this will return all of the stacks that are in the construct tree at the time that we make this call. We can also search up to find the stack that a construct is in. And when we do a search up, this ends up being like a non-throwing version of stack.of. So if you call stack of on a construct that's not in a stack, it'll throw. It'll say, we expected this construct to be in a stack, and it wasn't. Because usually when you're calling stack of, you really want that thing to be in a stack. And if it's not, you're going to be kind of surprised. So that's why it throws. But if you needed a non-throwing version, you could just call this, and it works just as well as stack of. It just doesn't throw. It'll just return undefined. I also have some typed helper classes in my CDK orchestration library. There's stack utilities for finding stacks, and there's CFN element utilities for finding CFN elements and CFN resources. And there are custom resource utilities for finding custom CFN resources. So I've just created these 3 helper classes, make it a little bit easier for you to find these types of elements, because I think they're ones that certainly I use a lot and I need to find in the construct tree quite a bit. So I created these utility classes, and they of course use construct tree search. And look, it's demo time. Okay, so let's go over here. Okay, so the first thing I'm going to do, as I said, is I'm going to show, this is the little AWS Toolkit plugin. You can get this plugin for VS Code, and it has Amazon Q and Explorer, and these have their own really neat functionality that you should spend some time looking at. But we're going to concentrate on this CDK part of the plugin. And you can see that it at the root, to represent my app, it has the path to my project. So here it's CDK orchestration examples, and this is where all of the examples that I use in this series are checked into. And so you can see under this app, there's a bunch of stacks. So you can see I'm creating a stack called finding constructs. That's this one right here. So finding constructs takes the app. It has an ID of finding constructs, and the IDs have to be unique under their parent construct. And here the parent construct is the app. And then I pass my environment. And my environment, again, I'm just using a dummy account, which is all zeros, and I'm using a region of US West 2 for this demo. Okay, and then I have these other stacks here, and I created these mainly to just show off the stack finding capabilities. And you can see that each of these has really just one resource in it, which is CDK metadata. They also have, I believe that one of these is a rule. I think check root bootstrap version is a rule, and bootstrap version is a parameter. That's like an SSM parameter that comes in. And so these all are basically the same. Now, this one, finding constructs, since, the whole point of this lesson is to help you find constructs, there are a lot of constructs in here. So, for example, there's a bucket, my bucket. It has under it a resource, and you'll see that after the resource, it says AWS : S3 : bucket. And so that's how you know that that is an L1 resource under the bucket. Now, this is also an L1 resource, this my CFN bucket. After I created a bucket, I created a CFN bucket, and it's called my CFN bucket. And you see that when I hover over it, it actually shows AWS S3 bucket. And so that's kind of useful. And that's similar to this other CFN bucket. This one actually has a child. Usually CFN buckets don't have a child. But this one does, and we'll talk about how that happened. Here I have a step function definition, and this has a whole bunch of step function steps in it, and these are just constructs. They're not L1 constructs. They're not L2 constructs. They're not even L3 constructs. These are just constructs, and they form part of the step function definition that I use to create this step function. So you can see that this is an AWS : step functions : state machine. So we created a step function state machine, and that has this resource. It also has a role under it, and it has this import role as well, which I believe that import role has something to do with accessing step function resources. And this step function definition also has a lambda under it and a role, of course. And so there's a lot of stuff in here. We have another state machine here, and then there's this is a provider for a custom resource that runs step functions. There's a lambda task. This is another custom resource, and yeah, it actually shows AWS : lambda : function. So that's, part of my lambda task here. Um, and, there are some other constructs in here that we can take a look at. I believe that this one here is actually also an L1, but when I hover over it, it doesn't show me the type of it. This would be a custom resource, and it just happens to not show that. I don't know what that's all about. Here's another provider, and here's another provider because I created an AWS custom resource. Actually, no, this is just a custom resource function is all that this is. This is not using the provider model, but this is used by AWS custom resource. And then we have our CDK metadata. So there's a lot of stuff in here, and you can see this all here, and you could use this to navigate using the node functions in the CDK. So you could say, from the stack, could say, if you wanted to get to the service role, you could say, try find child, hit a step function definition, and from there you can do a try find child of echo lambda, and from there you can do a try find child of service role, and that would get you to this role, and then you could make changes to the role. Oh, and I think you'd have to do resource as well, and then you'd be able to get to this role. Okay, so let's go and take a look at the tree.json file. So this file This is an interesting file. Oh, this is the top. Okay. So the tree.json file gives you a lot of information about your construct tree. And we'll just take a very short look at this so you can see that we have a stack object, and this is our stack finding constructs. This stack has a number of children in it, and so that's this finding constructs here, which is under the app, which is here. And then for children, the first child is my bucket. It gives you the ID, the path. It gives you, there's some attributes here that got added. There's the construct info here, such as CFN bucket. We'll take a look at this in a future video. Um, and this is really nice because this tells you that this is a bucket, and it gives you the path as well. So that's really useful if you're looking for, well, okay, I know that I created this construct and I know that there's a CFN bucket under there. How do I find that? So my bucket has a child, which is resource, which is a CFN bucket, and my bucket is an S3 bucket. So you have all of this information in here so that you can find the constructs in the tree. Over here, we have the template.json, and the template.json, for every resource that it creates, it also writes out some metadata, and the metadata here is finding constructs slash my bucket slash resource. This is the AWS CDK path, and this basically tells you where in the tree you're going to find the L1 construct that created this resource. Okay, so let's take a look at this finding constructs stack, and I'm going to show you how to do some powerful searches using this. And if I bring up this panel down here, I'm just going to run the build while we're going over this. And finding constructs is a stack because all of my lessons are stacks. And it says here in the help, it says you can't modify your CloudFormation template JSON if you can't find the L1 constructs that produce that JSON. Navigating the construct tree is not always easy, especially when using libraries with L3 constructs. Here we'll create a bunch of resources and then look for constructs in the tree. So the first thing I'm going to do is I'm going to get the app so that I can create some other stacks under the top level, and you see those stacks over here. We'll create those a little bit later in this lesson. And then here I set up some logging. I just like to use my own logging framework. And now I'm going to do a construct search. So this is a search, a construct tree search for the predicate is construct. And so the total number of constructs in the app right now is 2. And that's because I created an app and I created a stack. And at this point, we haven't created anything else. So there are 2 constructs in the app and only 1 construct in the stack. Okay, and so next we're going to create some predicates. And these are, I showed this predicate in the slides, is CFN bucket, and here's how I implemented it. I implemented it using CFN element is CFN element, CFN resource is CFN resource. So I'm basically saying if it's an element and a resource, and the resource type is the CFN bucket resource type, and that type is AWS : S3 : bucket, then that's a CFN bucket. And a bucket, however, an L2 bucket resource, which is normally the parent of a CFN bucket, and that's the one that you would normally create. You'd say new bucket instead of saying new CFN bucket. And construct is a bucket if it's a resource and it has a default child, and that default child is a CFN bucket. Then most likely what we have is a bucket construct. And so I feel pretty good about making this a type assertion for X is bucket. And resource is the base class for bucket. So that works. And in the same way that CFN element is the base class for CFN resource, and CFN resource is the base class for CFN bucket. So I'm pretty happy with these 2 predicates as written. Okay, so now we're going to start creating some resources. So we're going to create that L2 bucket that we found over here, my bucket. And we're going to do some assertions on it just to give you some idea of what this thing is like. So L2 my bucket has a default child. That default child has an ID of resource, which it does here. And so that comes out as true. My bucket has a default child. That default child has an ID of resource. Um, that default child is the same. Oh, the parent of the L1 CFN bucket is the L2 bucket. So we just checked that. And so L1 bucket for the L2 my bucket is a child with the ID of resource. The L1 bucket scope is the L2 bucket. So this is just validating that parent-child relationship. Now we're going to validate our predicates. Is CFN bucket? Yep, the L2 bucket is a bucket and the L1 bucket is a CFN bucket. And so that's these two assertions right here. And then I'm just going to show some negatives for a stack. So a stack is not a bucket and a stack is not a CFN bucket, just to kind of show you how these predicates work and how you can use them in your code. Okay, so now I'm going to do all the techniques from the slide. I'm going to get the default child, the resource child, by calling try find child with the ID of resource. I'm going to anarchically just access the underscore resource property of CFN bucket. And I'm also going to do a search using construct tree search. And if all of those return the same thing, then we're going to add some metadata where the key is Kirdan and the value is shipwright. And as you might have noticed here, that actually does end up in our template file. So that's just a way that you can add metadata to your bucket. Okay, so now we're going to create a CFN bucket. And this bucket won't have any children. Okay, so L1 bucket has no children? True. Our L1 bucket has no children. Okay. And is CFN bucket work on it? Yes, it does. Okay, cool. So now what's the total number of constructs? Well, there are 5 constructs in the app. That makes sense. We've got the app, the stack, the bucket that I created, its CFN bucket child, and then I created another CFN bucket. So that's 5, count them, 5 constructs. And the stack, of course, does not include the app, and therefore there are 4 constructs in the stack. Okay, so now we're going to create another CFN bucket, and we're going to turn this into a Frankenstein bucket. Happy Halloween, everybody. Okay, so from CFN bucket creates a Frankenstein L2 for an existing L1. So the reason that you might find yourself with a CFN bucket is because you imported existing resources into a new CDK stack, or you did a CFN include of an existing template into a CDK stack. And if you want an iBucket pointer to work with because you're calling some function that takes an iBucket and doesn't work with CFN bucket, then you would call this what they call a reverse escape hatch and what I call a Frankenstein. And so Frankenstein's bucket here, I'm creating a variable called Frankenstein's bucket, and I'm setting it to bucket.fromCFN bucket. And that's how we got this kind of crazy at from CFN bucket child of this bucket. And you can also see that over here in the template.json where um, my other CFN bucket, I thought this had a child called from CFN bucket. Really finding that weird. Oh, that's not going to be in the template.json file. Of course it's not. Why? Because it really doesn't have anything to do with the L1 construct. So because it's a child of the L1 construct, it doesn't make any sense for it to be there. You'll find it in the tree.json file here. So when I go, here's my bucket, Here's my other CFN bucket, and yeah, as a child called at from CFN bucket, but that doesn't appear in your template.json file. That actually makes sense. And then here it is here, so you can see it in these two places, but you won't see that in your template.json file. That actually makes sense. Okay. And so Frankenstein's bucket's parent is a CFN bucket, and the default child of Frankenstein's bucket is other CFN bucket. And that's a little weird because its parent is its child. This is kind of an I'm my own grandpa situation here. And this is a case where a default child is not actually a child of the construct. This is just kind of a weird thing about these reverse escape hatch or Frankenstein constructs is that the relationship between the L1 and the L2 from a parent-child point of view is reversed, but from a default child point of view is correct. So that's something that we can use when supporting Frankenstein constructs. Okay, so here is where I created that step function definition that I showed. And if you go and look in the code of this, you can see how to create a step function in the CDK. And I do this as a construct, and this construct implements iChainable. And that way I can call definition body from chainable and pass in that function into my state machine, and I can create my state machine, which we saw down here, and that creates a role and has a child, which is a CFN state machine. Here I'm creating a step function task, and this will actually run the state machine as part of my deployment, and it can monitor it for up to 4 days, although this is actually, I think, set for like 2 or 3 hours by default. If you wanted longer, you'd have to put that in there, and it does this just by creating a whole bunch of custom resources and, handing off monitoring of the state machine from one custom resource to another. It's kind of cool. And then here we've got a Lambda task. Now, tasks, my Lambda task and step function task, these are tasks, and they're very similar to CDK triggers. And the Lambda task is very similar in that it calls a Lambda, which is also what CDK triggers does. So I tried to make tasks and triggers very similar from that point of view so that wherever you can use a trigger, you can also use a task. And tasks just have a few uh, features that are not on triggers. I'll probably go over that in a future video. Now, this one's interesting. This is an import construct, and this is an L3 construct that's going to import a state machine from a file. So I have a template file here. This is a YAML file that was created by using the AWS Step Functions Data Science SDK for Python. So basically, I created a Python script. And my Python script can either deploy directly to an AWS account, or you can modify it so that it just writes out the template, or even just the step function definition. In this case, I modified my data science SDK application to write out the template, and then I import that template using a CFN import, and so that's going to get me a CFN state machine, and that would be a child of this. And so if we go over here and we look at step function import, you will see that way down in here it has a CFN import, and it has a state machine called state machine component, and this definition is the same one that you saw in that YAML file. So that's just a way. It just kind of shows how to bring external templates into the CDK. And lastly, I created this AWS custom resource. So I like using custom resources a lot in the CDK. This one is an S3 file resource. This calls S3 put object. So this is actually calling the AWS SDK from the CDK at deployment time. It will write out the body that I give it. So I can write any JSON string to it. And I gave it a bucket. So I'm writing it out to the L2 bucket. And it has a key of dummy.json. And if you haven't used AWS Custom Resource, it's really powerful way to create files or to create entries into a data table or things like that. And here I've given it a physical resource ID, which is the S3 URI of the file. I just created that right here in my um, CDK package so that I don't have to calculate it at deployment time. It's just here. I just know that this is going to be a valid S3 URI. And then you have to give it a policy because, of course, it's going to create a role. And if you look at this thing in here, my S3 file resource has a provider mechanism. It has yeah, this is a policy for a role, and then there's a role that it's applied to, which is this role, which is provided. This is a service role provided by AWS Custom Resource, and that's down here elsewhere in this file. Okay, so now that we've created all of these resources, let's go ahead and do some searches. So here I'm going to search for CFN resources. So I'm going to print out every CFN resource in the stack. There's 42 of them. So all of these constructs that you saw me create, I created 42 resources. And this is 42 uh, CFN resources. So these are 42 things that actually end up in my template.json. That is, if you went and looked at all of the sort of top level resources under resources in my template, you would find that there were at least 42 of them in here. And I think that that is correct, that it's 42. Okay. And the total number of constructs and let's just go to the bottom of this because there's an awful lot of them, all 42. The total number of constructs in the app is 108. And the total number of constructs in the stack is 179 because we haven't created any other stacks. So there's really just one more, and that one extra one is the app. Okay, great. Okay, and so that gets us to here. So now let's find the L1 CFN bucket that we created above. So now in the tree, I'm going to use my CFN element utilities. I'm going to look for a CFN resource. I'm going to start at the stack. I'm going to find one that has a resource type of AWS : S3 : bucket and a node ID of my CFN bucket. And look, yeah, that actually found my CFN bucket as we expected that it would. I'm going to do a similar thing here, finding a custom resource. Here I'm finding the custom Lambda task that we created above, and that is that greeting Lambda task that you saw earlier. And you can see that the actual resource, the actual custom resource, is way down under that Lambda task. It has a child of Lambda task, and that has a child of resource, and that has a child of resource, and that has a child of default, and that is actually the custom resource. So this kind of shows you that a Lambda task is in fact an L3 construct because it builds up from a number of L1 and L2 constructs, which is really sort of the definition of an L3 construct. Okay, so now let's take a look at stacks. Now that we've done some searching for resources, we'll search for stacks. So I'm going to create some predicates. Here I'm going to be creating a predicate is stack for a region. So you pass it a region and it returns a predicate function. So it actually returns a function, and that function will find the stack and find the region of that stack for the construct that you passed in. And it will say, is the region that you asked for? And the same thing for this one here is stack for account. It's just looking at the account variable and checking to see if the account variable is set to the account ID that you asked for. Here, again, this is returning a predicate. Okay, so we also looked when we were looking at the state machine definition, we were looking at these guys here. So state machine, this HIDL step function definition, HIDL stands for hardware in the loop, but this HIDL step function definition um, is a chainable, as are all of these other constructs, except for the echo lambda here, which is a function. All of these are all step function steps, and they're all chainable, which means that you can chain them together to form a step function definition. And so I did a search for chainable, and chainable is an interface. It has 3 properties, and those properties are ID, start state, and end states. And this will return true if the thing that you pass in supports the chainable interface. And so then you can use this as an iChainable after you've gotten it back. And then this one I actually had written as a type assertion, and this says that X is a state class. I could have made this a type assertion. That might be useful. And a construct is a state if it's chainable and if it has a state ID. And if you go look at the definition of the state class, you'll see that it seems like a pretty reasonable definition. If something is chainable and it has a state ID, it's most likely a state class. It's most likely part of a step function definition, and therefore I'd like to be able to find those too. Okay, so we now have these new predicates for stacks and step function steps or states. And now I'm going to create a bunch of stacks that I can search for. And again, I'm just using dummy account numbers. So I'm using this dummy account number 1, 2, and 3. And I'm using the regions US West 2, US East 1, and EU West 1. And so I'm just creating all of these stacks. And now we can do some searches. So here I'm going to create an array of stacks. And it's going to be all of the stacks for the region EU West 1, and that's dubbed for Dublin. And here I'm going to create a construct tree search for account number 2. And so I'm going to print out all of the constructs, that is all of the stacks in region EU West 1. And you can see that it printed out 1 EU West 1, 2 EU West 1, and 3 EU West 1. Then I'm going to print out all the stacks for account 2. And it printed out 2 US West 2, 2 US East 1, and 2 EU West 1. And so there you go. Those are the stacks. And you can see I used the numbers 2 and the letters for 1 here, just ended up doing that. And so that's what we see. Okay. So now and that's these 2 print statements. And so those predicates worked, and we were able to search for stacks. That might be useful for you someday. I've certainly found it useful myself. And here is another predicate, is Frankenstein. And this basically is checking for that reverse construct relationship where the construct that you pass in is a resource. It has a parent, that is its scope, its parent construct is a CFN resource, and its default child is its parent. And so we can search for those now too. So I'm just going to create a whole bunch of construct tree searches for is CFN element, is stack, is custom resource, is resource, so that's our L2 search, so this will search for L2 constructs, is Frankenstein, so that's our Frankenstein L2 search, is chainable, and is state. So let's do all of these searches. So first we're going to search for Frankenstein constructs. So our results for Frankenstein constructs, we got 1 back, and that's this at from CFN bucket construct that got created for us from my other CFN bucket. Okay, and here we're going to find all CFN elements in the stack. So the number of CFN resources in the stack, we're going to do a search down using our CFN element search from this, which is stack, and we're going to stop at stack boundary. So if there are any child stacks of finding constructs, which there aren't, because if you remember up there, I actually created all of these stacks using the app. So there are no stacks which are children of finding construct, but if there were, I would stop, because this search that I did here, this element search, this searches for CFN elements. It uses is CFN element. It does a search down starting at this stack and stopping at stack boundaries. So if there are any child stacks or substacks, any CFN elements in those won't be included. And so, how many resources do we have? Because we did that resource search earlier, where I printed out all 42 resources, and you can still see that, yet there are 42 resources, but there are 43 CFN elements. Why is there an extra CFN element? Well, let's find out. What we're going to do is we're going to print all CFN elements that are not resources. So we have a list of resources, and we have a list of elements, and we're going to filter out all of those elements that are in the resources array. And that is this import. And that is the CFN element. And that is because when you create a CFN include, that CFN include itself is a CFN element. Now, in this particular case, I don't think it's actually adding anything to the template, but CFN include creates constructs for most of the things in your template, but not necessarily everything. For example, if you had metadata in your template and it wanted to, that is CFN include, wanted to merge that into the metadata for the stack, then that would come from this CFN element and it would not come from any of the sub constructs that are created when you do a CFN include. CFN include creates L1 constructs for resources that are in an existing template. And in this case, it's doing it for that Python script that I had created that creates a template for me. Okay. So let's see, this is all CFN include constructs in defining construct stacks. That's the same as the CFN elements that are not resources. Okay, so now we're going to print all of the state machine states in the stack. And as I said, these state machine states, they're not L1, they're not L2, they're not L3. They're just sort of their own thing. And so we're going to do a state search for all of the states in the finding constructs stack. And that should be runs complete, echo step, run successful, succeeded step, and fail step. And you can see, yep, all of those are included here. And now let's take a look at all of the chainables. And that is all of these plus this one here, which is the HITL step function definition itself, which, as I said, this is a chainable so that I can use that construct, that parent construct, to create a chainable for my step function. Okay, now let's take a look at all of the stacks in the app. There's 8 of them, and let's print out all of the stacks that are under the finding constructs stack. And the only one that it shows is finding constructs because when you do a search down, it includes this pointer or the pointer that you pass in as the scope for the search down. And so it just printed out the one stack finding constructs. Now we're going to take a look at all of the custom resources in the app. So I'm going to use that custom resource search that I created, and I'm going to search down, and you can see that there are 3 of these step function task steps. So this is for my step function task. And so I believe that this means that we can wait for the step function for up to 3 hours because each custom resource can wait for as much as an hour. So that's how that works. And then our Lambda task is also a custom resource. And then our AWS custom resource itself is a custom resource. So those are the 5 custom resources in the finding constructs stack. Okay. So now we can also do a search up. I'm going to do a couple of those to demonstrate that functionality. So I'm going to start at that custom resource that we found. Uh, er, uh, I'm just taking the first custom resource that I found in the app. So I just say, get me a custom resource and just give that to me. And that's this custom resource. And if I got one, then I'm going to say found L2 for custom resource finding constructs. And so that found, since I did an L2 search up from the custom resource, that found this custom resource, my S3 file resource /default. and that's the custom resource, and that's the L2 that we found. So the parent of this is this default here. This is the um, L1 resource. So this is a CFN resource for a custom resource. And this one that says resource here, that's actually the L2. So these names get to be a little bit confusing at times. And so if you're trying to navigate and you expect the child of the L2 to be called resource, well, that's just kind of not the case here. And that happens sometimes in the CDK. And that's happening for this AWS custom resource. They don't necessarily expect you to be modifying these things, but I do. So, when I need to do that, I'll do a search because otherwise I'm navigating down a couple of steps and, they could even change that in the future. Who knows? Okay, and then found L2. What's this? Here I'm searching down from the L2 bucket that I created. So that's the first resource that we created. That's my bucket, and we're searching down for an element, and that's the CFN bucket. And I found that CFN bucket, and now we're going to do a search up to find the L2 bucket, and that did find the L2 bucket. And so uh here's the L2 bucket for this resource. Finding construct slash my bucket slash resource is finding construct slash my bucket. So that's just kind of nice to be able to search up for L2s. And you can also search up for stacks. And here we're going to do a stack search up from the L2 bucket. And this found for this bucket, my bucket, it found the stack finding constructs. So there we go. And here I'm just showing the search self, which is sort of the last search that's available on the construct tree search class. And this just allows you to do a test using using the predicate that you pass to the construct tree search. You can use that on a single construct if you want to, and that just saves you from having to have a pointer to both the predicate and the search. You can just use the construct tree search. And so at the end here, we have 187 constructs in our tree and 179 in our stack, and that's because we created not just the app, which would get us to 180, but we also created 7 other stacks. And so that's how we got to a total of 187. So hopefully this lesson will give you some idea of things that you can do in the CDK that maybe you hadn't thought of before, like being able to get to all of your L1 constructs or all of your L2 constructs or all of your constructs of a certain type. There's a lot of functionality in CDK orchestration because I do searches all the time. So hope you all had a great time, and I'll see you all in the next one. Bye-bye.